Hello everyone, in this video we'll be going over positive, negative, and zero exponents. So let's go over our definition of positive exponents. We know that exponents represents repeated multiplication. So for example, let's say we have this expression here. I know that this 5, this number on the bottom, that's going to represent the base. And this 2, that's in the upper right hand corner, that's going to represent the exponent. Or sometimes it's called the power. So, knowing that the base is 5, I know that 5 is what's going to be multiplied together, and this 2 tells me how many 5s we're going to need. So, since my exponent is 2, in total I need a total of 2 of these 5s. So, 5 to the second power is going to be 5 times 5, and that's going to equal 25. So, now let's figure out what zero exponents are going to be. And to do that, we're going to be completing this table here. So I know what 5 to the second power is, but what would 5 to the first power be? So since my exponent is only 1, I'm only going to have one term. And since my base is 5, I'm just going to have one of these 5s. How do I move up the table? How do I go from the first power to the second power? Notice how the only difference is this times 5. So moving up, I'm multiplying by 5. If I want to go down to the 5 to the 0th power, notice that I need to go down the table. So what's the opposite of multiplying? How would I move down the table? Well, the opposite of multiplying is dividing. So to move down, I need to divide by 5. Okay. So if I want to go down to the 0th power, I need to divide by 5 again. So what's 5 divided by 5? What would 5 to the 0th power be? 5 divided by 5 is going to equal 1. Notice how this works for any number. When I go from the first power to the 0th power, I'm always dividing a number with itself. And any number divided with itself is always going to equal 1. So 0 exponents always equals 1. Okay. Now let's continue our table to go down to the negative region. So let's figure out what negative exponents are. Like we said before, I know that to move down the table, I'm going to have to divide by 5. So if I want to figure out what a negative exponent is going to be, I need to continue dividing by 5. So 5 to the negative first power, that's going to be 1 divided by 5, or that's going to equal 0.2. Notice how when I have a positive exponent, I'm repeatedly multiplying, and when I have a negative exponent, this 5 is now on the bottom of the fraction. And when I have a number on the bottom of the fraction, that means to divide. So negative exponent represents repeated division. So using these definitions, let's go over some practice problems. So here, I want to figure out this positive, 0, and negative exponent. So 2 to the 4th power, since my exponent is 4, tells me I have 4 of these terms, they multiply together. Since my base is 2, I know that what's being multiplied are all of these 2. So 2 times 2 times 2 times 2, that's going to equal 16. All right, now let's figure out 2 to the 0th power. Again, just like before, to go from the first power to the 0th power, I'm taking 2 and dividing with itself. And any number divided with itself is always going to equal 1. So 2 to the 0th power equals 1. Now finally, let's figure out 2 to the negative 4th power. I'm going to take that 1, and I'm going to repeatedly divide. How many times are we going to divide? I'm going to have to divide a total of 4 times. So I'm going to take that 1 and divide it by 2, divided by 2, divided by 2, divided by 2. Notice how when I write these 2's on the bottom of the fraction, that means I'm dividing by all of these. So 1 divided by 2 for a total of 4 times, that's going to equal 0.0625. All right, let's go over our second example problem. Here I have 4 to the 3rd power, and using my definition of exponents, that means I'm going to have to multiply a total of 3 times, and what's being multiplied are all of these 4's. So 4 times 4 times 4, that's going to equal 64. All right, now let's figure out 4 to the 0th power. Again, when I take 4 and divide it with itself, that's always going to equal 1. Now let's figure out the negative exponent. So I'm going to take that 1 I'm going to repeatedly divide by 4. How many times do I need to divide by 4? I'm going to have to divide a total of 3 times. So I'm going to divide by 4, divide by 4, and divide by 4. So 1 divided by 4 for a total of 3 times, that's going to be 0.015625. Right? You guys might notice that when I have 5 to the positive exponent, to the positive 3, I'm multiplying by these 4 3 times. And when I have a negative exponent, I'm just taking these 3 4s and I'm moving them to the bottom of the fraction. So using that, we can come up with a shortcut for figuring out negative exponents. So here, I know that 3 to the second power, that's going to be 3 times 3, and that's going to equal 9. But let's say I want to figure out 3 to the negative second power. Well, since I'm repeatedly dividing, can't I just take 1 and divide it with this 9? So 3 to the negative second power is going to be 1 divided by 9. Notice how instead of having this 9 on top, when I have a negative exponent, I'm dividing by these 9s. And finally, let's figure out the 0 exponent. Again, any number to the 0th power is always going to equal 1. All right, let's do our last example problem. 7 to the 3rd power, that's going to be 7 times 7 times 7, and that's going to be 343. And if I want 7 to the negative 3rd power, what can I do with this 343? Can't I just divide by 343? So 7 to the negative 3rd power is going to be 1 over 343. And again, anything to the 0th power is always going to equal 1. So in conclusion, positive exponents represents repeated multiplication. When I take a 0 exponent, that's always going to equal 1. And when I have a negative exponent, I'm going to repeatedly divide.